Hello, everyone. My name is Zach Williams, and my project is going to revolve around the NBA MVP and then using machine learning to predict who will win MVPs in the future. Um, so, to dive right in, I'm going to go over my motivation for the project, some objectives that I have for this project, any initial challenges and questions that I've had so far, how the data structure is going to be, any mathematical and analytical description that I can provide to you right now, preliminary analysis that I've done, and a analytical plan and timeline. So to dive right in, why don't we talk about the motivation? Um, so there's two main reasons that I want to do this project. One is I'm obsessed with basketball. It's been my favorite sport for most of my life now. Um, I love the data people who are around the basketball industry, um, along with all the statistics that go along with it. There's a lot of people who are super smart and able to break this data down into chunks that are digestible to the basic viewer and basically be able to make their own judgments and stuff like that. But basically, a lot of the work I do outside of school, I do it with basketball statistics because it's a lot of fun. I understand it really well. And I love basketball. So that's reason number one. Reason number two is I wanted to create some sort of project that I would be able to finish now, but be able to grow into something much bigger as time goes on. Um, so for now, by the end of the 8 weeks, I want to be able to predict the MVP based on previous data that I'll dive into later. But I want to be able to use machine learning to predict who will be MVP next season. And basically, that's it, just through different modeling methods that I'll discuss later as well. But basically, something that I can give an answer to now, but can grow over time. When I talk about growth, I'm referring to some of the other nuanced stuff that goes into voting for MVP. One of them being that the voters are all media members. And so they obviously post their predictions on who will be the MVP at the end of the year. They post their votes. Sometimes they make them public, which is really nice from a data collection standpoint. And so being able to use something like sentiment analysis to go scrape through podcasts and Twitter and even articles that they write for their companies and whatnot to basically figure out what the media is saying about certain players. So, for example, last year, the MVP ended up being Joel Embiid, when a lot of the data pointed to a player, Nikola Jokic, who played for the Denver Nuggets, being the MVP by kind of a landslide based on his statistics. So while if I did this last year, the model would say that Nikola Jokic would win MVP, but really Joel Embiid won because the voters, one way or another, decided it just through the grapevine, whatever happened. I believe he had a really big performance towards the end of the year. That was a good push. The Denver Nuggets team as a whole wasn't very good at the end of the year, even though they ended up winning the title by the end of it. But in any case, as a more broader focus other outside of basketball, I wanted to create something that was informative and impactful now, but also create something that can grow in the future with time. All right, a few of the main objectives are figuring out what statistics are best for predicting who will win the NBA MVP, what columns in the Excel spreadsheet is the best way I'll put it, are best at accurately predicting the MVP by the end of it all. We can use a few different methods to figure that out, but basically I want to figure out what parameters are great for predicting MVP, and so we can sort of track who's leading certain categories throughout the year and be able to look at who might win that way as well. Number two is to take the findings from the prediction model and then compare and contrast them with what the sports betting markets are saying. This is how it all ties into my industry and what I do for work. I work for DraftKings Sportsbook. and basically am around all this sort of stuff all the time. Super interesting. It's a lot of fun to work there, but I wanted to have a project that tied into that a little bit. So what the plan is to take what the model predicts who will be MVP and then compare it to the sports betting lines. And so I'll use DraftKings, I'll use websites like FanDuel, BetMGM, Caesars Sportsbook, even ESPN's new one if they have it up and running by NBA season, and basically compare and contrast which ones might be good value bets, which ones might be chalk is what we refer to as like the favorite, almost the most likely to win, and then basically see if there's any sort of way we can make money on this based on the industry. And number 3 is who will obviously win in 2024. We can't predict during these 8 weeks who will win, just because the NBA season doesn't start until after the 8 weeks is over. Well, technically I'll have about 4 days worth of data to work with. But basically around the end of November, we'll have data and we'll be able to accurately predict the MVP in 2024. And basically after that, just going probably either bi-weekly or monthly, observing how the lines have changed, observing how the models changed with new data, all that fun stuff to see how it changes throughout the year, because it's 82 games, it's a long season, anything can happen. So I am excited to get started on those 3 objectives. So the initial challenges and questions I have for this problem broke it down into a few different categories, and this isn't all the questions that I'll have or answer throughout, but these are just a few I wanted to touch on. The 5 question categories is how I outlined it. But who's the target audience for something like this? Is it advanced analytics communities as a whole? Is it nuanced to basketball analytics? Is it something that can be translated into like other sports? Who exactly am I targeting with this is something that I'm going to answer as I start developing the probably the work in progress too in the final presentation. Just basically as I'm creating the presentations, just trying to narrow who my audience is exactly, and then catering to that. What variables will be the most impactful to predicting MVP? I obviously spoke on this a little bit earlier, but basically figuring out like, are any advanced statistics more or less better than basic statistics when viewing the MVP, when trying to figure out who the MVP will be at the end of the year, that sort of stuff. How far should we go back in our data? I'll talk about this a little bit. I did kind of answer this question, but and when those data become outdated, like I said, I'll answer that a little bit more later on. Where can I find all this data? Again, I will answer that later on, but I don't have any other work questions. So, and then how are we going to extract the most important data? That's something that we're still struggling with, and basically how to get all the data that we deem necessary, condense it down to what we actually need, and then modeling it from there. That's a question that I'm going to answer hopefully soon. So moving forward, our data structure, we have about, I think, a little under 30 spreadsheets for all of this that we plan on combining into one big master spreadsheet. And basically we'll combine them all with merges and Python. It should come out hopefully good. But basically there's 5 different, I think there are 5 different spreadsheets that we're going to use. 2 of the main ones are per game and advanced. We have them from 2013, 2014 season on. Per game stats are stuff like points per game, 3-pointers made per game, field goal percentage per game, stuff like that. Advanced, you get a little bit more into some of the statistical work that basketball community has done so far. Basketball Reference does a really good job of creating these new statistics that are super helpful in looking at how well players are performing, essentially. So like true shooting percentage is something that's a big statistic in sports. It's really important to player performance, offensive rebound percentage, defensive rebound percentage, so on and so forth. Basically, how many rebounds you're grabbing in a game based on the total amount of rebounds grabbed in a game. Those are going to be our two largest spreadsheets. I believe there's something like 20-ish columns in each one. So that's where a lot of our data is going to come from. Another data source is team standings. So we'll take every year the standings for each team. We'll match them with the players and the per game and the advanced stats. And we will see if team win percentage, I think is what we decided, is going to be a accurate predictor for MVPs in the future. Because you noticed most valuable player is what MVP stands for. And so how do we define value in the NBA is something that's often discussed. It could be the best player on the best team, obviously provides the most value because their team performed the best. That sort of initial thinking is something that is going through my head when looking at all this data as well. Another chart, this is just one sheet, MVP voting. The MVP voting is posted publicly after all the voting is done. The actual physical votes themselves aren't like who voted for who, but how many points did first place get over second place. So this chart right here shows that Kevin Durant got 119 first place votes, which awarded him however many points out of the maximum amount of points. And so his MVP share is going to be the percentage of points that he earned towards first place. And so that's MVP voting kind of in a nutshell. I'll get more in detail about it probably in the next couple of presentations, but for now we can sort of leave it there. And then this is another advanced statistic, excuse me, that 538 came out with called Raptor. It mainly is for measuring player performance on and off the court. So how well a player performs per 100 possessions compared to an average player is basically what on-off metrics are rooted in. Raptor goes a little bit further than that and gives a player a score based on offensive and defensive contributions. And so you kind of see usage percentage isn't really taken into account with any of this. So we're going to dive into that a little bit when we're looking at the data a bit. But basically, the more a player is impactful on the court to winning, the higher the Raptor score is going to be. So the higher the number, the better you are. And it's broken down into offense and defense. So if you're really good at offense, but really terrible at defense, it's going to balance out in that sense. So those are the 5 major spreadsheets that we're going to use. Obviously, there's more per game and advanced data than team standings, MVP voting, and Raptor, but there's still a lot of data. It's going to be a huge data set. Like I said, around 30 spreadsheets in total with just 50 probably rows of data in each one. So that's very exciting to have a massive data sheet at the end of that, to have a bunch of historical data and the MVP or on the NBA going back to 2013 and 2014. All right, mathematical and analytical description. So kept it a little simple here because I haven't really dived into this part yet. But I can talk about a few things. So the main model that we're going to use is regression-based models. We're going to use a couple of them, see which one works best in predicting the MVP and all that stuff. Stuff like support vector models and random forests are going to be our best friends in this. It's not classification. We can't just say MVP is 1. Everyone that's not MVP is 0, because that's going to be hard to predict who the ones are. So we're going to use regression. We're going to use percentage of MVP share, as I mentioned before, for our measurement to test against. And then evaluating that, we're going to use R-squared and mean sum error. Those are 2 measurements that are going to be really effective in how well the model is predicting MVPs. They're inversed. I believe R-squared is the lower the value, the better, and mean sum error, the higher the value, the better. I could be wrong. It could be inversed. I get them confused. But I'll double check that and make sure it's correct in the next work in progress when I have a little bit of this stuff figured out and hopefully have maybe a prediction, but we'll see. And then obviously charts, both comparative and descriptive, when we get to the sportsbook lines and stuff like that, comparing and contrasting it with our model. The charts are going to be super helpful because we're going to be able to see basically, like, we could probably just use a scatter plot where the model has a point based off of the betting lines on a different axis, and you can look at it that way and compare, contrast, and see which website has a better odds for the favorite, something like that. And then, yeah, descriptive, that'll dive into maybe what parameters are best for predicting MVP and stuff like that. Any preliminary analysis that I've done so far, like I mentioned, not a lot. Still working on merging all the data. That's goal number 1. Hopefully by the end of this week, I'll have that done. But getting all those spreadsheets into one big master spreadsheet, and then being able to determine what the minimum requirements are for an MVP. For instance, in the NBA's history, who had the lowest points per game that any MVP has scored. Excuse me. And eliminating anyone who had average points lower than that, because obviously we're not going to set some sort of record for who the MVP is this year, like with low statistics. I've already looked through the data a little bit too, determined that some columns aren't really necessary in the overall modeling, might screw it up a little bit. Stuff like every table has a rank. Some of them are arbitrary, some of them are important. So figuring out which ones are important, leaving them in, getting rid of which columns aren't really necessary for modeling, it might screw up our predictions. So that's going to be really important. And then finally, an analytical plan and timeline. So I lay out a little bit how the 8 weeks I would like to go. The first 2 weeks, I spent a lot of time figuring out which data I wanted to use. Well, backtrack a little bit, figuring out what I wanted to do for a project, which was actually pretty easy for me to do. I did a project similar to this in our Tableau class, which was just taking descriptive statistics, advanced statistics, and throwing them on a dashboard and being able to compare and contrast different players, how they perform with advanced statistics and stuff like that. Basically figuring out what the idea was going to be for this, and taking that idea, figuring out what data I needed to collect for it. As I just talked about, the 30 spreadsheets and all that, have that all set. And then, so this week specifically, I've been doing a lot of data cleaning and preliminary observations that I talked about, getting rid of columns that I might be able to get rid of, and basically combining all those spreadsheets into one. That's the goal at the end of this week, is to have one massive spreadsheet for all of it, bring it into Python to reduce it based on parameters is something that we're going to be able to do starting next week. In weeks 4 through 6 is a lot of the heavy lifting for the modeling, the analysis, checking out which charts might be good for describing impact of different variables on MVP, how well our model performed based on previous seasons. one note I want to make is to test and see if this model is actually accurate. I'm going to take the results from 2022, 2023. So, and see how well it predicts that year, to see if it'll work for 2024. And then week 7 and 8, just fine tuning the visuals that I want to use for the final presentation, making sure I have everything squared away and prepared to present the final product and the final findings to you guys. So that's my project in a nutshell. Yeah, I'm super excited to start doing it. It's something I've been thinking about for a really long time, just haven't really had the time. And I thought the Capstone project was a perfect way to finally do it. And it's super relevant since the NBA season kicks off right after this class ends. So I'm super excited to get started on this, and show a final product that hopefully wins people money. That would be great. So yeah, like I mentioned, my project is about NBA MVP and how we're going to use machine learning to predict who is going to win the MVP. And with that, I will sign off. Thank you, everyone.